Excellent. So now that we've gone through and we've had a little bit of a look at how symmetry works with the unit circle, we're actually going to use this information when working with exact values, in particular the special triangles. So let's go through and have a look at a couple of worked examples, shall we? Now the very first example, which is something that you might come across, is it says find the exact value of sine of 150 degrees. Now, this is where you might go, oh, I haven't really worked with 150 degrees before. All I've really worked with is 45, 30, 60, and of course your 0, 90, 180, 270, etc. But never 150 degrees. Well, this is actually where the symmetry comes into play. And you're going to go through and watch exactly what happens. So let's go through and check it out, shall we? Now it says find the exact value of sine of 150 degrees. So the very first step that we need to do is go through and draw a line to where 150 degrees is. So where's that going to be? Well, it's going to be in the second quadrant, isn't it? Because 150 degrees is of course more than 90, but it's less than 180. So therefore this angle here is 150 degrees. So let's just think about this a little bit and how we can use symmetry to help us out. Now, we know that the angle in the second quadrant, well, it's going to be 150 degrees there, but the angle in the second quadrant, well, if that's 150 degrees and this here is 180 degrees, what's this angle here going to be? Well, it's going to be 30, isn't it? So that means that this angle here is 150 degrees, or in other words, 180 degrees minus 30 degrees, isn't it? Now, because of that, we know that this angle here is 30 degrees, and we can use this information to help us solve or simplify, in other words, what sine of 150 will be. And this is how we do it. What we need to do is we need to figure out, well, sine of 150 is the same as saying sine of 180 minus 30. We agree with that because 180 minus 30 will be 150. So, of course, that means it's true. But because I know that, I know that there's actually two angles that will give me that answer, isn't there? And so therefore I can figure out that 150 degrees is going to get me this point roughly. Or if I continue it all the way across and make my angle here, well, that angle here is going to be the same as saying 30, isn't it? So therefore, sine of 150 degrees, of course, will be the same as saying sine of 30. It's going to get me the same answer, isn't it? Now, because I know sine of 30, oh, wait a second, I actually do know sine of 30 because that comes from the special triangles, doesn't it? And here's our special triangle. Now, sine of 30 degrees, SOHCAHTOA. Sine means opposite over hypotenuse. So that means we've got the 30 degrees because we're doing sine of 30, and we need to do opposite over the hypotenuse. So therefore my answer will be equal to 1/2. And sure enough, if you go through and on your calculator and put in sine of 150 degrees, you'll actually get 1/2. So let's go through and do another example, shall we? It says find the exact value of tan of 150 degrees now. Now, of course, whereabouts will 150 degrees be? Well, it's going to be in the second quadrant because we just did it. And why is that? Well, it's because more than 90, but it's less than 180. So 150 degrees goes here. But this is where it becomes a little bit more different because we know it's in the second quadrant, but we're going to use symmetry now to help us out with this. Now, we know that this angle here, once again, is going to be 30 degrees, and therefore tan of 150 degrees is going to be the same as saying 180 degrees minus 30 degrees. So we know that this here is 150, so therefore it's the same as saying 180 minus 30. And why do we use the 30? Well, we always want to know what this angle is from here to here, so that we can then figure out what it's going to be in the first quadrant. So let's go through and do that. We know that it's going to go across to there, and then it's going to go across to here, and therefore our line's going to be over here, like so. And that means that that there is going to be 30 degrees. But this is where it gets interesting because we can see that only sine is positive here, not tan. So therefore, it's going to be our negative answer of whatever tan of 30 will be. Because once again, sine's the only one that's positive here, not tan, and we're looking for tan of 150 degrees. And tan's only going to be positive if it's down here. So therefore, we know it's going to be the same as saying negative tan of whatever that angle was, which happens to be 30. Now, can I figure out negative tan 30 or tan of 30? Well, yeah, I can, because I can use that special triangle again, can't I? And tan of 30, well, tan, SOHCAHTOA, is equal to opposite over our adjacent when working with 30 degrees. So therefore, opposite is 1 over root 3. But because it's in the second quadrant, only sine's positive, so therefore it's going to be negative 1 over root 3. Oh, that should say a negative there. Just ignore that for now. Alright, but what else do we need to think about in terms of this? Well, we can't have a root 3 on the bottom, can we? We've got to rationalise it, so therefore we get an answer of negative root 3 on 3. So tan of 150 degrees is equal to negative root 3 on 3.